sine alpha t minus g t squared over 2. Now I remind you again, I want to find y as the function of x, not y as the function of t. So what I do, because it's the same t, I'll isolate it from here, so it's x over v cosine alpha, and place it here and there. So I'll get y equals 0, I don't care, multiplied by t. T is x divided by v cosine alpha, plus minus g over 2 multiplied by t squared. T squared is this squared. V squared cosine alpha squared. Okay. Again, this and this. Okay, sine alpha over cos alpha is tangent alpha. It's better to know this equation, okay? Sine alpha over cosine alpha is tangent alpha multiplied by x minus, I'll write it, g over 2v squared cosine alpha multiplied by x squared. Again, look what I got. Y equals 2. This is constant. This is like ax minus. This is also constant. bx squared. It's exactly a parabola equation. So it means that if I wanted to draw this parabola, it will be in a cry mode because it's minus b, it's negative. The coefficient of x squared is negative, and it's easy to see that if I put x equal to 0, so y will be also 0. So it starts here. It's something like that. If we want to find these points, you can, if you like. How do we find this point at the parabola? I remind you, this point, if you want the x, is minus b, minus, I wrote it, don't write it like that, it's better to write it in the other way around, minus a squared, minus a x squared plus b. This is a, this is b, it's better like that, x. It's exactly the same, minus a squared x plus b. If you want to find this point at the parabola, this is the equation, this is the x to find it. If you want to find this point at the parabola, just place 0 at the y and isolate the x. You'll get both x, this x and that x. And this is exactly what happens here, exactly. But we know how to find this point. This is a mathematical way to find this point. We know how to find it like we did earlier. We know it stops in the y direction. So we write v final equal to 0 and we find it. This is another way to find it. Okay, so now we proved that the path in which the ball is moving upon is a parabola. Okay, one more. Let's do a little tricky mathematical problem, there I want to show you, and then another thing with mathematical problem. Okay, so the question is like that. I know I throw a ball at the velocity of 100 at an angle I don't know, and I want it to reach this point. Let's say this h is 50 meters, and let's say the range is 200 meters. And the question is, what angle should I choose in order to reach this point? Let's do it, okay? It's a practical question. I know that I have a gun or something, and I want to aim the gun or the whatever I have in the exact angle in order for it to reach a certain point. How do I do it? Again, the same idea. We'll get a little mathematical trick here. I want to show you it. Okay, so let's do x v t y0, y, v0, v final, a, t. Okay, first of all, again, we divide it into two separate velocities. Cosine alpha, 100 sine alpha. Okay, so let's start writing what we know. Again, this is the origin, this is the positive here, positive there, okay? If it's not okay, it's your problem because this is what I want to do. But you can choose this as origin and this positive, it doesn't really matter. Okay, x0 is 0. X final, I do know, it's 200 meters. The velocity, I do know, part of it anyway, 100 cosine alpha. Time, I don't know. Okay, why? Y0 is 50 meters. Y final, I do know, it's 1. It's a 0 because it starts here, it finishes there. V0, I don't know, is 100 sine alpha. V final, I don't know. A, I do know, it's minus 10 because we talked about it. Okay, so the idea exactly the same. Let's write equations here, equations there. At the time will be the combine. It will combine the equations. So if I choose, let's start with this one. So 200 equals to 0 plus 100 cosine alpha t. So 200 equals to 100 cosine alpha t. I can divide it by 100, so 2 equals to cosine alpha multiplied by t. This is what I can write with this equation. Now let's go to this one. I'll take the third one. Okay, let's put numbers. 0 equals to 50 plus 100 sine alpha t minus 5t squared. This is what I know from this, from the y-axis. Now I want to, the question was to find the alpha. So again, the t, it's what helps us to solve these problems. Let's isolate it from here and put it there. So I know that t equals to 2 over cosine alpha. I put it here. 0 equals to 50 plus 100 sine alpha multiplied by 2 over cosine alpha minus 5 multiplied by 2 squared over cosine alpha squared. Okay, so let's see what I got. 0 equals to 50 plus sine over cosine, we said it's tangent, so it's 200 tangent alpha minus 20 over cosine alpha squared. Okay, let's see about this question. First of all, we can solve it because it only has one variable, which is alpha, but we need a trick, a little something you should know in math. In math, in trigonometry, we should know that this is exactly the same. If you don't know it already, you will learn it later on in maths in school, but now I'll give it to you. This is a known fact in trigonometry. So what I can do, it's like I have it here, 1 over cosine squared alpha. So instead of this, I can write that. So I'll get 0 equals to 50 plus 200 tangent alpha minus 20 1 plus tangent squared alpha. Now I can solve it. I can choose another variable, let's say m. I'll call it tangent alpha. It will be easier. And I'll get 0 equal to 50 plus 200m minus 20, 1 plus m squared. This I can solve. 0 equal to 50 plus 200m minus 20m squared. So 0 equal to minus 20m squared plus 200m plus 30. I'll do mode 5, 3. minus 20, 230. I'll get m equals to 10.1478 or m equals to minus 0.1478. And I remind you, each m is really tangent alpha. So now I can find the alpha from each equation. If I do shift tangent, mode 1, shift tangent to 10.1478, I'll get 84.37 degrees. And if I'll do shift tangent to minus 0.1478, I'll get minus 8.407 degrees. If I was not mistaken. So it means if I want to reach this point, I have two options. Or 84 degrees, it will go something like that. Or minus, it means under the horizontal axis, minus 8 degrees. Something like that, minus 8 degrees, so it will go like that, something like, not straight line, also a parabola, but okay. To check it, if I'm not mistaken, I can check it. I have a way to check it. I can take the angle, for example, the 84.37, and place it here in this equation and see if it reaches 0. So I'll do 50 plus 200 tangent ans minus 20 over cosine ans squared. Not exactly. Maybe I have a mistake. Just a minute. 10.1478 shift tangent 84.372. Okay, cosine ans squared minus 20 divided by that plus 15 plus 200 tangent 84.372. It's almost 0, so I think it's okay. Okay, I hope I'm not mistaken. Just a minute. If it's a mistake, I have a number mistake, but I think it's okay. I hope it's okay. And really, it doesn't matter. It matters that you understand how to deal with these kind of problems. You find the x, you find the y, everything about the x, about the y, the t combines them together. And the trick is sine over cos is tangent, and 1 over cos sine squared, you use this equation. This is the main idea. And from here on, I think it's okay. 20. And again, if it's not okay, it doesn't matter. Okay. More. Okay, another nice thing to show about this kind of problems. Let's, again, we need a little mathematical trick here also in trigonometry. Okay, the question is like that. I think we all tried it. We can all throw a ball or a stone, something, with a certain angle. I want to know which angle to choose in order that the ball will reach you understand me? We reach as far, the ball will go as far as it can. Okay, I want to know what angle to choose. I have a certain velocity I can throw it with. In the certain velocity I can throw it with, which angle to choose in order that the ball will go in the maximum range. So obviously, intuitively, it should be 45 degrees because it's something symmetrical. Why it should be more than 45? Why it shouldn't be less than 45? Obviously, it should be something like 45, but let's prove it. Okay? So the question is, what is alpha in order to reach the maximum range? Again, let's do x, y. So x0, again, this is the origin, positive, positive. X, what? Okay. X, v, t. y0, y, v0, v final, a, t. Okay, x0 is 0, x I want it to be the maximum x there is. V, we should separate it to v cosine alpha, v sine alpha. So once we do it, v will be v cosine alpha. y0 is 0. Y finally is also 0 because it reaches the ground. So with the y-axis, it reaches the same place as it started with. v0 is v sine alpha. V final, we know it's a symmetrical problem. We can write minus v sine alpha, but really it doesn't matter. A is minus g. Again, I write g instead of 10 because it's a problem with letters. And t, I don't know. Okay, let's write the equation. If I write this equation, I'll get 0 equal to 0 plus v sine alpha t minus g t squared over 2. We can divide it by t because t is, we cannot divide with 0 equations, but t is obviously different from 0 because it will take it some time to reach this place. So I'll get v sine alpha minus g t over 2. Now let's write the equation here. X equals to x0 plus vt, so x equals to 0 plus v cosine alpha t. Now again, the t from here and the t from here are the same t. Let's isolate it from here and put it there. So I'll get 0 equals to v sine alpha minus g over 2 multiplied by t, multiplied by that. X over v cosine alpha. Okay, let's write it like that. Gx, I'm moving this to this side. 2v cos alpha equals to v sine alpha. Let's isolate the x. X equals 2. I multiply by that, so it's 2v squared cos alpha sine alpha, cosine alpha sine alpha over g. This is the x as the function of alpha. If I choose this alpha, I'll get this x. Another alpha, I'll get another x. Now there is another thing in trigonometry we should know. You will learn it, or you may have know it already. Sine 2 alpha is equals to this. This is a known fact in trigonometry. So instead of these 3, I can write that. So I'll get x equals to v squared multiplied by sine 2 alpha over g. This is how, if you saw it in class, maybe you saw this equation, this is how they got this equation. Now I can show you how I find what angle I need to reach the max range. V is obviously constant. It's the velocity I threw it with. G, constant. Sine alpha, what we know about sine alpha? Sine alpha, sine 2 alpha, it doesn't matter, it's always a number between -1 and 1. This is a known fact also in trigonometry. So if I want the x to be maximum, so the sine must be maximum. So I want the sine 2 alpha to be the maximum that it can be, which is 1. And now I go to the calculator and I do shift sine 1 90 degrees. So 2 alpha must be 90 degrees. So alpha must be 45 degrees. And this is the proof that if we choose 45 degrees, I'll get the max range. And if I want to know what the max range is, sine alpha is 1. So the max range is v squared over g. But I can say one thing about these kind of equations. I advise you really not to learn this equation, not to use these equations. Use this method. Whatever problem you get, write everything you know about the x, everything you know about the y, and then put the equation like we did today. I showed you certain things, that certain equations that are developed from this method, but this is the main idea how to deal with these kind of problems. Okay, let's do one more. And now I'm going to show you a problem that if you try to use these equations, you will be wrong. Why? Because I'll add something in the problem. Okay, let's say this is the problem. I have a tower which is 80 meters, and I throw a ball like that. Velocity, okay, 50, angle 36.87 degrees, but I also have wind, and this wind makes the ball accelerate in this direction, let's say 4 meters per second squared. So I add a little something in this kind of problems. All what we did before is irrelevant because now I have acceleration in the x-axis. But still, if we know how to deal, like I showed you, in the usual way, it will be easier to solve it. What will happen to this ball? I really don't know. Why? Because many things can happen. Let's assume it will go up and down. Maybe in the x-axis it will not be enough, it slows it down obviously, but it's still, maybe it will go somewhere here. Maybe it slows it and exactly stops it. If it exactly stops it in the x-axis, it will be with no velocity. Maybe it doesn't only stops it, it stops it and make it move back. Maybe it will go like that. Maybe it will go like that. Maybe it could be that it stops it before it reaches the top. So it goes up, stops, and then still climbs, and then go back. Many options we can have here. We don't know, and we really don't care. Why? Because if we work like I showed you, we'll know what will happen. So let's ask 2 questions about this problem. Let's find what happened and then ask what should be another acceleration in order to happen that something else will happen. Okay, so let's start dealing with the problem like we did before. First of all, we divide the velocity into x and y. So let's do it. This is 50 cosine 36.87, it's 40. This is 30. I told you why earlier. It's Pythagorean, 3 numbers that usually work with the Pythagorean theorem. It's 30 squared plus 40 squared equal to 50 squared. But again, I'll just make sure, because I like to make sure. Really, it worked. Okay. So x, y. Again, this is the origin, this is the positive here, positive there. Let's see what's going to happen. Okay, x0, x. Now I need all the 6 variables because it accelerates. y0, y, v0, v, t, a, t. Okay. let's start. x0 is 0. X final I don't know. A, I want to know what will happen when it reaches the ground. A is minus 4 because the positive way is this, and A is that. Even though, maybe we don't know yet, maybe it only slows it and then it reaches the ground. Maybe it slows it and accelerates it back in this direction. The A will remain minus 4 because the A, the acceleration, doesn't change. The velocity may change. The A is constant. V0 is 40. V final I don't know. Time, obviously I don't know. Okay, Y0 is 80. Y final I do know it's 0 when it reaches the ground. V0 is 30 plus because it's in the positive direction. V final I don't know. A is minus 10 obviously. Let's find everything, okay? I want this, everything. So from the y-axis I use this equation. So I'll get 0 equal to 80 plus 30t minus 5t squared. What do you say? I'll get good result or bad result? Okay, let's see. Minus 5, 30, 80. Good result. I don't believe it. T equals to 8 or minus. Minus I don't care. It will take it 8 seconds to reach the ground. So if I find 8 here, automatically 8 there. Because this is what we learned today. The time it reaches the ground is exactly the time it moved this direction. Okay, let's find the V final in the y direction. Vt we call it. So V final will be V0 is 30 minus 10 multiplied by 8, which is minus 50. Okay, when it reaches the ground, the velocity is 50 downwards. Okay, now let's go to the x. Let's find the x first with the third equation. x0 plus v0t plus 8t squared over 2. So x equals to 0 plus 40 multiplied by t minus 4 multiplied by t squared over 2. I think it's fine. I hope I'm not mistaken. V0 I say 40, time is 8, A is 4. Okay, let's see. Mode 1. 40 multiplied by 8 minus 4 multiplied by 8 squared over 2. 192 meters. So now we know it finished there, it didn't finish here. So we don't know if it went back, maybe it didn't stop, it just slowed down. We know it when we find V final. If V final will be plus positive, it means it's in this direction. If it will be minus, it means it is in that direction. So let's find it. V final must be, should be, V initial is 40 minus 4 multiplied by 8, it's 8. Okay, so it means this ball, whatever, it's still here. It didn't go back, it didn't stop, it didn't go back. And the range is 1 and 2, and if we want to find the velocity, this is 8, this is in the y direction, we found it's 50, we can find the v, we can find the alpha, we can find everything we want. Okay, this is a good example. How do we deal when we have acceleration? How we deal when we have acceleration in the x-axis? Let's ask another question regarding this problem. What should be A? What the acceleration of the wind should be in order that the ball will reach the origin? The ball reaches the origin. Okay? I want to know what A should I place here that the ball will go like that. Okay? Again, I write the y, I write the x. The y, y0 is 80, y is, okay, let's just wait, v final, a, t. in the y-axis, there's nothing is going to change because it still starts here, finishes there, velocity is 30. So all the data we have here is exactly, I can copy it, 8 and minus 50. But in the x, something is missing. Again, if I have 8 seconds here, it will be 8 seconds there. Initial x is 0. I want the final, the final position to be also 0. The v0 is 40. So this is the question. What the a will be? Let's place it in the equation. In the, I think this one. Okay, so x will be 0 equals to 0 plus 40 multiplied by 8 plus 8 multiplied by 8 squared over 2a. Okay? Yeah. So 0 equals to 3 to 20 plus a multiplied by 32, I think. So a equals to minus 10. I think. I think so, okay. It doesn't really matter again if I'm mistaken, but the idea is what's important. If the acceleration in the x-axis will be minus 10, it will slow it down and then start accelerating it backwards, and it will reach exactly the origin. And I can ask any other question I want. For example, what should be the acceleration in order for it to stop, to reach the ground vertically? What does it mean vertically? That there will be no velocity in the x-axis. So what will I change here? I'll change, instead of x equal to 0, I'll change v final equal to 0, because I don't want any velocity in this direction. Okay, this is the idea to solve problems, again, with accelerations. Now let's do something final, because I think the idea is, you understood the idea. Something very nice, and I'll show it in two ways. It will be very nice to finish this lesson with this problem. Okay, this I have the ground, tower. Let's do with letters, okay? This is H, and I have a ball here that doesn't move. V0 is 0. But also, there is wind here, but the wind is in this direction, and let's say the acceleration is 2g. And also there's acceleration, obviously, g here. And I want to know what will happen to the ball. How long it will reach the ground, what kind of path is going to go upon. It will be maybe a parabola, maybe a straight line, maybe something like that. I want to know the path in which the ball is going to move. In other words, I want to know the y as the function of x. The origin is here. This is the positive in both directions. Again, there are two ways to deal with this kind of problem. And I want to know the final range also. Let's do the x, let's do the y. I start with the x. Again, I have 6 variables here because it accelerates. Y, y0, y, a, t, v0, okay. First of all, let's find this equation, okay? I want to show what path it's going upon. Okay, so x0 is 0. X final is x. Remember, when I want to find a function, I leave the x as x. v0 is 0. V final, I don't know. A, I do know. It's 2g, and it's positive because it's in the positive way. T, I don't know. y0 is h. Y final, I'll place y because I want, again, I want y as a function of x. I want to know when I find an x, what will be the y? What will be the height? A is minus g because this is the positive direction, g is this direction. Time I don't know, v0 I don't know is 0. Okay. Let's use this equation for both of them. When I put this equation with these variables, I get y equals to y0 is h, v0 is 0, a is minus g t squared over 2. So y will be h minus g t squared over 2. Let's write about the x. Again the same equation. X equals to x0, which is 0, plus v0, which is 0. A is 2g t squared over 2, because the t and the t are the same. T and t goes. So x equals to g t squared. Now again, our third time today, we want y as the function of x. So let's isolate the t squared here and place it here. So I'll get y equals to h minus g over 2 multiplied by x over g. So y equals to h minus that. Very interesting. Look what I got. Y equals to, I'll write it like that, minus half x plus h. So what's our conclusion here? This path is a straight line. It's like y equals to ax plus b. It's a straight line. So the ball will go like that, in a straight line, not a parabola. If I want to know exactly how to draw this line, it's easy. When x equals to 0, y equals to h, which is obvious, when x is 0, y is h. When y is 0, let's just find the x, we'll get this. So we'll get half x equals to h, x equals to 2h. So it's a little more like that even. So it started here with h, it finishes here. So the path will be like that. More like that, like that. So now I know everything. I know that the path will be a straight line. I know it will reach here 2h. And I also know that I can find the angle in which it goes. If I want to find this angle, it's easy because tangent alpha equals to 2h divided by h, which is 2. So alpha is 63 point something. We had it today also. Shift tangent 2.43. Okay, so and now even if I want to know, I know it reaches the ground in the same velocity, in the same angle. So this angle and this angle are the same. If I want this one, I'll do 90 minus. If I want to find the velocity, it reaches the ground. It's easy also. I can find, we didn't do it, but I can find the v. Well, let's do it. Let's do it. I want to find the velocity it reaches the ground. So let's find the final velocity here, final velocity there, and combine them into resultant velocity. So how do I do it? Okay, v final, let's start with the y. V final equals to v0, which is 0, plus g as minus g, multiplied by t. T is the square root of... I need to do a little more. Okay, just a minute. I need to have more space here. Okay, I'm wiping it off. Let's find the final velocity again. So if you want the final velocity, we can put we know that the final x is 2h, and the final y is 0, and then we can find the v final. And the t, if you want the t, I wiped it off. Anyway, let's use this equation, okay? 2 multiplied by a multiplied by x minus x0 equal to vt squared minus v0. I can use also this one, and then I don't need a t. So 2, if I work with the y axis, I'll get 2 multiplied by minus g multiplied by 0 minus h equals to vt squared minus 0 squared. So it's 2gh squared. Okay, so 2gh. And now if I want to work with the x, I'll do exactly the same. 2 multiplied by 2g, which is 2h minus 0 equals to vt squared minus 0 squared. So it's 8gh squared equal to vt. Square root of 8gh. So what we know, in the x-axis it has square root of 2gh, here it has 8, here it has 2gh, and if we want here to find the velocity, we know it's exactly the same angle here. We'll do square root of this squared plus that squared. So it's 2gh plus 8gh, which is 10gh. Okay, now we know everything. We know it goes in a straight line, we know the angle it does, we know it reaches the ground with this velocity in this angle. If you want that angle, then just do 90 minus, it's 90 minus 63.43, which is 26.57. If you want this angle, it goes down h, it moves to h. Okay, this is one way to deal with this kind of problem, and we know we already seen it many times today. Now I want to show you something very, very nice in physics, another way to deal with this kind of problem. Okay. Again, I want to prove, now I need to prove that it goes in a straight line. What do I know about this ball? This ball is resting, is not moving. It feels two equations, two accelerations. It feels 2g here and 1g here. So it feels a resultant acceleration g squared plus 4g squared, which is square root of 5g. So suppose this is the ball, it feels only one acceleration. This is the acceleration it feels. We divide it into two different acceleration because it's easier for us to deal with when we work like that. But really the ball feels only one equation, one acceleration. So it will move according to this acceleration. It will move in this path. Just because it was starting with v0 equals 0. If it had, like all the other problem we dealt with, a velocity in the x direction or the y direction, then it won't move on this path because it will also have the velocity in the other directions. But if it starts with rest mode, with v0 equals 0, it will just go with the acceleration. So it will move in a straight line. And we know it when we leave a pen and drop it. Why does it move downwards? Because it moves according to the acceleration. The acceleration is down, it moves down. If I give it also velocity here, then it goes in this way and it goes like that, and we know how to deal with it. But if it starts with rest, in rest mode, it will go exactly where the acceleration is going to be. So the idea is when an object is resting and it feels an acceleration, it will always go with a straight line with the acceleration. So it will go like that. Now I don't need this kind of methods to deal with this problem. I can easily find this angle or this angle, it doesn't matter, let's find this angle. So tangent alpha is g over 2g, always y over the x. So alpha is shift tangent half, come on, 26.57 degrees, exactly the same we got before. We got this one, 63. So it will move in this direction with the angle of 26.57. The acceleration will be that, v0 is that, and if I want to know, this is h, and if I want to know where it reaches the ground, it's easy. This angle is exactly this angle. So I can do tangent 26.57 equals to h over x. X will be h divided by tangent 26.57. And if I want to know how much it is, remember there's a 1 here. Do in your calculator 1 divided by tangent, and you will get 2h. So this will be 2h. And if I want to find the velocity, I can write the equation as if it was a straight line. So I only write the 6 variables just for this line. x0, let's say this is the positive way, this is the origin, so it's 0. X, we can find it like from here, because this is 2h, this is h. If we do Pythagorean theorem, we'll get square root of h squared plus 4h squared, which is square root of 5h. v0 is 0, v final is what we want. Acceleration is square root of 5g. Time I really don't care. I can find it if I want. Let's choose, I think this one also. So I'll get 2 multiplied by that, multiplied by that, equals to that, minus 0. So 5 is 25. Sorry, it's 5 is square root of 5 squared root of 5. 5 multiplied by 2 is 10gh equals to vt squared. Vt equals to square root of 10gh. It's exactly what we got earlier when we did it with x and y. So, just to open your eyes, if a certain object is moving on a straight line, you don't always have to divide it into x and y. You